relativistic force equation. Hello everyone, this is Aditya, and today we are going to study relativistic force equation. And pardon me for my absence. I was not making videos since long because I wasn't well, but today I feel better, so I thought to record this lecture. So today we are going to study relativistic force. So what is it, relativistic force? Let's study that. But for that, please do like, share, subscribe, and please support this video. Now let's start. So what is the use of this relativistic force term? Well, let me tell you. Suppose there is an object, suppose of mass 100 kg, okay, and suppose you are giving it a constant acceleration of a is equal to 10 meter per second square, right? So it basically means you are providing it a constant force according to F is equal to ma of the unit of the quantity 1000 Newton, correct? Okay, 1000 Newton. So this is the force which you are providing. This is the constant force. Constant force. Okay. Right. Now, what's the problem in this? Well, the problem is that if you use equation of motion over here, since it's a constant acceleration, we all know that acceleration is dv by dt. Correct? Okay. So from here you can say dv is equal to a dt, and when you integrate it, suppose it is initially at rest and it goes to velocity, suppose velocity v for now, and you integrate it from 0 to t, right? So you get v is equal to at, right, since initial velocity is 0, right? Now what is a? A we have calculated as 10, and what is t? We don't know. So velocity over here is given as 10t, correct? But what's the problem? We have got a nice expression for velocity. The problem arises that when you set velocity as speed of light, it will be when c is equal to 10t, so you will get t is equal to 3 into 10 raised to the power 8 divided by 10. So it means that time is equal to 3 into 10 raised to the power 7 second. What it means? It means that if you apply 1000 Newton constant force for a time period of 3 into 10 raised to the power 7 seconds, the body will approach towards the speed of light. So it means that there is a linear relation between velocity and time. Of course, it was clear from the graph itself, from the equation itself, right? V is equal to 10t, where slope is tan inverse of 10, correct? Now clearly this is absolutely absurd thing. Why? Because we all know that no object can travel at or faster than speed of light, because we all know that if any object has mass, it cannot travel at the speed of light or faster than that. Then how can we say that if you apply 1000 Newton constant force for a time period of 3 into 10 raised to the power 7 seconds, the body will acquire the speed of light? No, it's not possible. To solve this problem, we use the concept of relativistic force. So let's see what is it now. Now let's come to the fundamental definition of force. What is force? Force is actually rate of change of momentum. You represent it like this also, right? Okay. So F is equal to dp by dt, right? So what is momentum now? Well, we all know that momentum is given as gamma times mv, right? Now many people say that you can write over here m naught and you can write mv, where m is the relativistic mass now. But relativistic mass is now an older term. Why? Because clearly the mass of an object is not increasing when the velocity is increasing, right? The amount mass is an intrinsic property of an object, so it won't change. What actually happens is that the kinetic energy change increases, due to which we feel it as an increase in mass, right? So instead of saying relativistic mass, we can just use this expression: P is equal to gamma times m naught v, right? And if you want to define what is m naught is clearly the mass of the object, but if you want to specify over here, you can say it as rest mass, okay? But it doesn't matter actually, you say it as mv or m naught v times gamma. Both will give you the same result, but if you talk about physical correctness over here, then I would go with this, okay, instead of mv, because relativistic mass is just a concept, not actual reality of universe, okay? So f is equal to dp by dt. It is just a mathematical tool to help us in our calculations, okay? So f is equal to dp by dt. Now let's solve it. So f is equal to d by dt gamma m naught v, right? Now clearly, if there is acceleration, then there will be change in velocity. It is obvious, right? Okay. So now m naught is clearly a constant. This is the mass. So m naught will come out d by dt gamma times velocity, right? Now what is gamma? Yeah, I forgot to tell. Gamma is a Lorentz factor over here, defined as 1 upon 1 minus v square by c square. Correct? Gamma is equal to 1 upon 1 minus square root of 1 minus v square by c square, right? Where v is the velocity, but since it is v square, so it will be just speed over here, right? So gamma, of course, is a scalar quantity, right? So now just use differentiation over here. F is equal to m naught d gamma by dt times velocity plus gamma times dv by dt, correct? Now this is the actual equation of force which we will be using, right? Now one thing, suppose if I am talking about uniform circular motion, over here, right? This is the velocity vector, correct? This is the radius, okay? So if the object is in uniform circular motion, correct, then in that case the speed is equal to constant. We all know it, right? So what will be change in gamma with respect to time for UCM? For UCM it will be equal to 0, because clearly gamma is a function of speed over here, right? So if speed is constant, then if you do its derivative, if you find its derivative, it will be equal to 0 itself, right? Because there is no change. So for UCM, f turns out to be m naught. This term will vanish, so it will be gamma times m naught. What is dv by dt? Dv by dt, you say it as normal acceleration, okay? So from here you can clearly see that as velocity approaches towards the speed of light, the force will tend towards infinite force, right? So as the velocity is increasing, the force is not constant anymore, it is increasing, right? You can clearly see from this expression, right? Now let's erase this, and now let's solve for the general expression, right? So we had got f is equal to m naught times v d gamma by dt plus gamma times, right? Now we have to differentiate it with respect to time, right? Okay, so let's see. So gamma can be written as 1 minus v square by c square raised to power negative 1 by 2, right? We can write it like this. Correct or not? Okay. So gamma is equal to, just check it. It's mathematically that expression only. Just see it yourself. Solve it, okay? So when you differentiate it with respect to time, since c square is a constant, of course, velocity is a function of time. Velocity is of course a function of time. Velocity you can say, or speed over here, okay? So this is the expression. So d gamma by dt is equal to negative 1 by 2 times 1 minus v square by c square negative 3 by 2, correct? X is to power n d by dx is n times x is to power n minus 1. This is what I have applied over here, correct? Now by the chain rule you will get negative 2v by c square times dv by dt, correct? Right? Okay. So this and this will get cancelled, this will become positive, and from here you get d gamma by dt is actually, what is this expression? This is equal to gamma cube. So it is gamma cube times v by c square dv by dt. Okay. So from here you have got this expression. Now let's plug in over here, right? And let's see what we get. So we had got d gamma by dt was equal to gamma cube times v by c square times times dv by dt. We have got this expression. Yeah, we had got this expression previously, right? Okay, so now let's substitute it over here. What you will get? You will get f is m naught times the quantity v times this quantity. It will be gamma cube times v square by c square plus gamma dv by dt can be taken as common. Okay, right? Okay. Of course, this is now for linear motion I'm talking about, or non-uniform circular motion over here, right? Okay. So we have this expression now, and yeah. So f is m naught. Now, how can you simplify it? Well, that's the biggest question now. So you can take gamma also common. So when you take gamma as common, you'll get gamma square v square by c square plus 1 times dv by dt, right? Now let's simplify this expression. Let's see what we get. So what is gamma square? Gamma square will be 1 minus 1 by v square by c square times v square by c square, correct? I am multiplying now. This is gamma square, this is gamma square, and this is v square by c square, right? Plus 1, correct? Now let's simplify this a bit. We will get v square by c square minus v square plus 1. If you don't know, just simplify it once, right? C square will come in numerator and c square again will go in the numerator, right? So you will get 1 minus 1 by c square by c square minus v square times v square by c square and c square will get cancelled. So you will get v square by c square minus v square, and now you solve it, you will get v square plus c square minus v square divided by c square minus v square. It is clearly equal to c square by c square minus v square, which is equal to 1 by 1 minus v square by c square, which is gamma square. So actually this term is gamma square. So from here you get f is m naught gamma cube dv by dt for a linear motion mostly. So f is gamma cube m a. This is the relativistic force formula over here, correct? Just check it once. So now let's take the previous example, you are applying an acceleration of 10 meter per second square. The body is of 100 kg. It is at u is equal to 0. Now let's apply the same equation. I mean the equation which we have derived. F is gamma cube times m a, correct? So you will get F is equal to 1000 gamma cube, right? So this is velocity, this is gamma. Now clear graph I don't remember right now, but it is somewhat like this. When velocity is equal to 0, then gamma is at 1, right? Gamma is at 1 when velocity is 0, and it keep on increasing and it tends towards infinity as velocity is approaching towards the speed of light. And similar graph will be for gamma cube also, right? So it means that when velocity is tending towards the speed of light, force is tending towards infinity, you will require an infinite force to reach to that speed, the speed of light. And now it's well inside the framework of our universe. Now let's derive kinetic energy using this expression. Let's see how we can derive. Now what is kinetic energy? Well, work done is the integral f dot dx is equal to the change in kinetic energy, right? So suppose the body is over here and you apply a force and it goes to some arbitrary point, suppose at x, and now it is moving at velocity v, and you are again applying a force, right? So what you get over here? Let's see. So basically 0, suppose initially it was at rest. So initially it was at rest, okay? 0 to x ma gamma cube times dx is change in kinetic energy, correct? Now what is a dx? We all know that v dv by dx is equal to a, so we can say it like this, right? Okay, so we get integral from 0. Now clearly when suppose this is at x is equal to 0 and u is equal to 0, of course, right? So at x is equal to 0, u is equal to 0, correct? And when x is equal to x, then velocity is equal to some v, right? So we have m gamma cube a dx. We can write it as suppose let's name it as some alpha, right? Because you will get confused then in this variable and in that. So let's name it as alpha, correct? M gamma cube times v dv is equal to change in kinetic energy, right? Now let's evaluate this. Now it's very simple actually. How? We will have, what is gamma cube? It is 1 minus v square by c square raised to the power 3 by 2, right? It is this expression. Now wait, let me check my mic. Yes, it's okay. So we have 0, we have this expression. Now we have gamma cube, so now you can just clearly integrate it. 0 to alpha, m is a constant, v dv by square root 1 minus v square by c square whole cube, right? Now let's name 1 minus v square by c square as some t, not time, it is just variable t. So we have dt times c square, right, is V dV. Correct? Right? Check it once. Yeah. So it is M integral. We will check for limits in a few moments. But for that we will check it over here. C dt by negative 2 times t raised to power 3 by 2. Right? And now let's solve. So you will get mc square negative 2 negative 1 by 2. When you will integrate, you will get t raised to power negative 3 by 2, and when you add, you will get t raised to power negative 1 by 2 negative 1 by 2. This and this will get cancelled. So you will be left with mc square t raised to power negative 1 by 2. Now what will be the limits? We have to solve for limits first of all. So limits will be over here when v is equal to 0, t is equal to 1, and when v is equal to alpha, then it is 1 minus, okay, 1 minus alpha square by c square. Correct? So we have mc square times 1 minus alpha square by c square negative 1 by 2 minus 1. What is this? This is gamma. So kinetic energy at any moment is mc square gamma times 1. This is the expression for kinetic energy. Now what you use in classical mechanics, in classical mechanics the velocity is very less as compared to the speed of light. So gamma is 1 minus v square by c square negative 1 by 2. So gamma approximately turns out to be 1 plus v square by 2 times the c square. This is the binomial expression over here, right? Now when you put it over there, you will get kinetic energy is equal to mc square times gamma minus 1. So 1 and 1 will get cancelled, v square by 2c square. So kinetic energy turns out to be half mv square. Correct? So for velocities very less than the speed of light, the kinetic energy expression is half mv square. We proved it also from the binomial expression over here. And the actual formula for kinetic energy is equal to mc square gamma minus 1. So as the velocity is approaching towards the speed of light, the kinetic energies keep on increasing at a very fast rate, and when it approaches near the speed of light, it almost tends towards infinity. So it means that if we want to give an object with mass the speed of light, you need to give it an infinite kinetic energy, which is of course impossible, right? So this is the whole theory behind kinetic energy and relativistic force. And one more thing over here we say mc square as rest mass energy. So the total energy of an object is kinetic plus rest mass energy. So it is mc square gamma minus 1 plus mc square. So total energy of the object is gamma mc square. Now don't worry, I will tell how mc square is derived, but not in this lecture, in some other lecture of relativity. So I hope so that for now everything is clear whatever I taught, and I hope that you enjoyed this video. If you did, then please do like, share, subscribe, and please support this video. And I'm really sorry I wasn't well, so I couldn't make the video. I'm really sorry again, and I'll try to be regular now. Okay, so till then, bye bye, take care, and all the best.